We want to look at this topic in mathematics, matrices and determinants. And first thing here, can look at the meaning of matrix. The singular form here, the singular of this is simply matrix or matrix, as it may be pronounced. And this can be defined as a rectangular array of numbers. As this a set of quantities, we can say a set of quantities, usually in number form. So if we have to define matrix, so we can say a set of quantities, usually in numbers, usually in number form, that is arranged in rows and columns, arranged in rows and columns, and enclosed within a large bracket. Enclosed within a large bracket. So here we have the definition for matrix. So a set of quantities, usually numbers, arranged in rows and columns. So the keyword there we have rows, column, and we have enclosed. So it's usually arranged in rectangular form, actually. So it has a row, column, and enclosed a bracket. So let's have an example here. So e.g. we have a matrix. Here we have this number arranged 5, 1, 3. Then also we have 2, 4 minus 3. So enclose in a bracket like this. So this is a matrix. Look at it. We have two rows here. The row is the horizontal arrangement. So when you know horizontal is like we have a straight line like this. So and you have this the first row, second row. So we can say this is row 1. And here we have row 2. So we have two rows here. And the columns is 3 here. So we have 3 columns. Columns are vertical. So vertical, like you have vertical line. So all this one now, this 5 2 is the first column. So we can say column 1. Here we have column 2. And here we have column 3. Which implies here we have 2 rows and 3 columns. Okay? And now that we have defined a matrix, there's something called order of a matrix. The order of a matrix means the arrangement of a matrix, and it's usually written in form of row by column. So generally, order of a matrix is always written as row by column, row by column. So row is coming first and column is coming second. So for example, in the example above, the order of this matrix now, when we look at this in form of row by column, so this order of above example is now what? When you look at that, that's 2 rows. So that will now be 2 by 3, which means we have 2 rows and 3 columns. So now what we are saying is that if we want to write order of any matrix, the row is coming first before the column. So it's form of ordered pair under Cartesian plane. Whenever we have Cartesian plane, there is something called ordered pair. Ordered pair. And that's always written in form of x comma y. So it's also applicable under matrix. So the ordered pair here, row first before column. So having any matrix, you should be able to write the order. So rows coming first before the column. All right. Then also we have something called the notation of matrix. Notation. So when we have a matrix, matrix is always denoted as capital letter. So we use capital letter to denote a matrix. Capital letter to denote and the elements inside in small letter. So elements will now be in elements in small letters. In small letters. Okay. Now let's give an example here. For instance, let's have a matrix A and say the element inside here we have, we use a capital letter here, and the elements we have 1 minus 3, 0, 2, 4 minus 4. Now, these are the elements inside this matrix A. Now, what is each of these elements saying? We should understand what these elements mean using the idea of row and column. Okay, now when you look at this, what's the order of this matrix A? On the order of the matrix, we have 2 rows, row 1, row 2, and we have 3 columns, column 1, column 2, column 3. So the order of this matrix now is 2 by 3. 2 by 3, right? That's 2 rows, 3 columns. And this matrix means that when we interpret it, A is now equals to element 1 here is element in row 1, column 1. Look at it, row 1, column 1. So we can say we have A11. And minus 3 here is element in row 1, column 2. That's A12. The subscript we are writing here, the first one means row, the second one means column. So row 1, column 2. And here we have A13 now. We are still in row 1, then column 3. So the first one serving as a row, and the second number there serving as a column. And when we get here now, this 2 now means A21. It means elements in row 2, column 1. And here we have A22. That's element in row 2, column 2. And here we have A23. So this one means element in row 2, column 3. So that is it. So we use small letters to denote the element of the sets, and we use capital letters to denote the matrix itself. Okay. Now let's look at this particular exercise to illustrate the order and the elements that we have seen. Okay. You're watching at Master T Matla, so do it to subscribe, share this video, and follow us for more interesting videos. So don't miss out on our live videos. Okay. So like in form of exercise now, let's look at this. We have this matrix. This matrix, we have let A be equals to we have the element 1 0 minus 2 3 4 minus 5, and also we have another matrix B, and B is given as, okay, so B is given as 5 minus 3 minus 4 2. Now these are the two matrices given, and the question say determine question here the order of A and B, the order of matrix A and B, okay, and also question B. So give to this video, God bless you, also share it. Question B says we should determine from figure 1 A12 from figure 2 A22 from figure 3 A32 from figure 4 B11 from figure 5 B41. Now easily we can do this fast and get the solution here. For the first question here, you will say determine the order of A. What's the order of matrix A? When you talk about order, we know that we are writing the row by column of that matrix. So now matrix A has an order of how many rows? That's 3 rows. So we have 3 by 2 columns. So 3 by 2. Very direct. So once you understand what you are doing, you can see that on the matrix A that it has 3 rows and 2 columns. And also matrix B has an order of, look at matrix B now. You discover that we have like 4 rows and just 1 column. So we write this row by column, that's 4 by 1. 4 by 1. Then question B now, that one has said that we should find the elements A12. That is A12. A here means is in matrix A, because since capital letter A is used for the matrix, the element there will be denoted in small letters. Okay, so A12 means element in matrix A, which is in row 1 and column 2. So each of these subscript written here has a meaning. First number is on the row and second number is column. So it means element in matrix A, which is in row 1 and column 2. And when you look at it, this is row 1, and this is column 2. So element in row 1 here, column 2. So we have 0 here. So that means the first one, which is A12, is equals to 0. The second one, which is A22. A22 here means element in row 2, column 2. So row 2, column 2, that's 3. And from figure 3, also we have A32. A32's element in row 3, column 2. Row 3 here, then column 2, that's minus 5. Then Roman figure 4, we have B11. Elements in the matrix B now, because we have the matrix B of row 1, column 1. Row 1, column 1, that's 5. And Roman figure 5, we have B41. That this element in matrix B, which is in row 4 and column 1. So it's having only 1 column, row 4. That's 2 there. So that means we have solved this particular problem. All right. So you're still watching us live at Master Timas class. So stay tuned. Now we have some types of matrices. So let's look at different types of matrices that we have. Okay. We have types of matrices. The first one we look at here is a row matrix. A row matrix. As the name implies, a matrix with just one row of elements. That's a row matrix. A row matrix has only one row. E.g., we can say we have matrix 1 or 6. So this matrix now has just one row of elements. And here it has 3 columns. So which means when we want to write the order of this matrix now, row by column, I mean 1 by 3. So it has just one row and 3 columns. That's number 1 types of matrix. And number 2, we have a column matrix. So similarly, just as the name implies, a column, just only one column of elements. So e.g., we can have 2, 0, 5. This matrix has only one column of elements, and it has how many rows? 3 rows. And when you write the order here, row first before column. So we have 3 by 1. So this matrix has another 3 by 1. That means 3 row, 1 column. So that's what you have as column matrix. Just one column of element. And also, we have another type of matrix. And the next one, that's 0 or null matrix. 0 or null matrix. This kind of matrix has all the elements 0. So all the elements inside this kind of matrix are null, that is 0. E.g., when we have something like 0, 0, 0, 0, we discover that this element inside this matrix, everything, they are zeros. So it means we have a null or 0 matrix. And number 4, we have what is called a square matrix. A square matrix. Then this kind of matrix, according to the name, is square. It has the same number of row and column. It has equal number of row and column. So if it has 2 rows, it also has 2 columns. So a square matrix, equal number of rows and columns. For instance, we have a matrix A, and that be 1, 3, minus 2, 7. We discover that this here, we have 2 rows and 2 columns. That is 2 by 2. Or that 2 by 2. So this is an example of a square matrix. It has an order of 2 by 2. Okay. So a perfect example of a square matrix. Also, we can have another one. Let's say matrix B now is also having element of 1, 0, 4, 4, 3, 6, 8, 7, 2. Now, this kind of matrix is also a square matrix. Why? It has 3 rows of elements, also 3 columns. So, equal number of rows and columns. So, we call this 3 by 3. It's also a square matrix. Now, another type of matrix, number 5, we have a diagonal matrix. A diagonal matrix. And this matrix has all the elements, actually is a square matrix. So this is a square matrix whose all elements are zeros. So a square matrix whose elements are all zeros, except those in the leading or main diagonal That's a square matrix. E.g., now let's pick any of this. Look at this. Let's say matrix A now. Everything now, assuming everything is zeros, except those in the leading diagonal. Okay, let's put it where we can see. E.g., we have matrix A equals to 1, 0, 0, 7. This now has the element 0, except the elements in the main diagonal, that is the leading diagonal here. So that is what they call a diagonal matrix. Also here, we can change this one to a diagonal matrix. It's only 1, 3, 2 that we are going to have. All other one will be 0. This is what we're seeing. So another example, that matrix B now cannot turn to 1, 0, 0, 4. Sorry, 4 now, that will be 0. So 0, 3, 0, 0, 0, 2. So the only diagonal that is having element is the leading diagonal or the main diagonal. So this is a perfect example of a diagonal matrix. Also, we have a unit or identity matrix. So we have number 6, a unit or identity matrix. Identity matrix. So this matrix is a diagonal matrix. It's a diagonal matrix. Remember what the diagonal matrix is, okay? So this is a diagonal matrix. So a unit matrix is a diagonal matrix whose elements in the leading diagonal are 1. E.g., we can turn this one to a unit matrix and we say we have unit matrix of 2 by 2. So that will be 1, 0, 0, 1. So the elements in the main diagonal here are 1. The same way we can turn this B now to a unit matrix. We just change everything in the leading diagonal here to 1. So this will be 1, 1, 1. So that's what they call a unit or identity matrix. So you are watching us live here at Master T Math Class. So share this video, give it a thumbs up, and also subscribe. Now let's look at another subtopic here, which is addition and subtraction of matrices. Addition and subtraction of matrices. So we have addition and subtraction of matrices. Now, two or more matrices can be added and subtracted. Now, let's look at the general way of handling this. It's very direct. So it means we add and subtract the corresponding elements. For instance, if we have matrix A to be equals to, let's use a 2 by 2 matrix here. We have A11, A12, A21, A22. So we know what this one means. And also we have matrix B, and this, let it be B11, B12, B21, B22. Now we can add matrix A and B now. Okay, so we can say then A plus B will then be equals to, so the element of A, the corresponding element of A with the corresponding element of B added. Okay, this is what we have. A11 plus B11, that's element in row 1 column 1 plus element in row 1 column 1. Then element in row 1 column 2 plus element in row 1 column 2, that's A12 plus B12. This means we are adding the corresponding elements together. Same thing here, we have A21 plus B21. Here also we have A22 plus B22. And also A minus B is also going to be, we subtract the corresponding element. So that's here, A first, that's A minus B. So we have A11 minus B11, then A12 minus B12, and A21 minus B21, A22 minus B22. So that is how we add and subtract. Now let's look at this as exercise. Given, or let A be a matrix, so let's take this as exercise. So we can say let A be equals to matrix. Here we have a 3 by 2. We have 2 minus 4, 3. And we have 5, 1, 0. And also we have matrix B, and this same thing as 1, 4, minus 2, minus 3, 3, minus 1. Okay, and the question says find from our figure 1 A plus B, from our figure 2 A minus B, from our figure 3 B minus A, because A minus B is not the same thing as B minus A. So we can lay our eyes on this and put your answer in the comments. Let's see who is solving this correctly. All right. So now, when we lay our eyes on this and we put it following the general way of adding and subtracting, we discover that this here is very simple. So this matrix has 3 rows. Has 2 rows and 3 columns. That's 2 by 3. Also same thing as 2 by 3. So we can easily add and subtract. So now when we do it together here, let's do the solution here. So we can say that the first one, A plus B, that we are finding, will then be equals to the element in A we have this, elements in B we have this. So the adding the corresponding element. That means we have 2 plus 1, then minus 4 plus 4, then 3 plus minus 2, then also 5 plus minus 3, then 1 plus 3, 0 plus minus 1. Then we can finalize the answer here. 2 plus 1, that's 3, minus 4 plus 4, minus 4 plus 4, same thing as 4 minus 4, that's 0. So this is simply 0. 3 plus minus 2, when you have plus minus, plus times minus, this is minus. So two different signs will give us minus. So plus minus give us minus. So 3 minus 2, that's 1. Same thing here, we have minus. 5 minus 3, that's 2. 1 plus 3, 4. 0 minus 1, that's minus 1. So here we have the results of A plus B. Okay. Then for A, the second question here, for A minus B, this also, we are going to subtract now. Subtract the corresponding element. So A first now. So A, that's 2 minus 1. Also minus 4 minus 4. And 3 minus minus 2. 3 minus. Then we have minus 2. Then we have 5 minus minus 3. Then 3 minus 1. Then, sorry, you have to be careful when you are solving so that you don't go and miss it up. You know, is what you are doing is A minus B. So A should come first. We got it to this place because we have been writing A first. Now, what's in here is 1. And 1 minus 3, yeah, I believe we got that. Then also 0 minus minus 1. 0 minus minus 1. So we try to manage the board, okay? And the results here, can we write it? Let's show here, okay? So that we try to. So this now, 2 minus 1 is 1. Let's write it here. So the result number 2 here, 2 minus 1, 1. Minus 4 minus 4 give us minus 8. 3 minus minus 2. Minus minus turn to plus. So same sign. Same sign is plus. Different sign is minus. So minus minus is plus. So 3 plus 2, that's 5. Also we have plus here. 5 plus 3, that's 8. 1 minus 3 minus 2. 0 plus 1, that's still 1. So the result to A minus B is this. Okay? So now, B minus A, for the number 3 question here, it means that B is coming first. So we take B first. That means 1 minus 2. Excuse me. Now, here, also 4 minus minus 4 minus 2 minus 3 minus 3 minus 5, 3 minus 1 minus 1 minus 0. Then when we write it out, this becomes 1 minus 2 minus 1, 4 minus minus, that's 4 plus 4, that's 8, minus 2 minus 3, that's minus 5. So all this one are the basic thing that we need to understand how to add. We have minus 2 minus 3. Some students do find this difficult. directed number. Very important. The minus 3 minus 5, that's minus 8. 3 minus 1, that's 2. Minus 1 minus 0 is still minus 1. So we have this as the result for B minus A, actually. So adding and subtracting matrices is as easy as this. So we do it directly and then we solve it. I believe you enjoyed this class. This is Master Team class. So do it to follow us, subscribe, share this video, give it a thumbs up, and stay tuned. We upload video daily in mathematics here, which could be of interest and help to you. And also we go live like this. So don't miss out. See you in our next class. And bye for now.